Intro to Logic Part 7, Validity. A valid argument is one in which it's logically necessary that if the premises are true, then the conclusion is also true. An invalid argument is one where it's logically possible that even if the premises are true, the conclusion is still false. So invalid is just the negation of valid. It means not valid. You can see in the picture on the right, we have an invalid argument. 2 is a number, 1 is a number, therefore 2 is 1. In this case, we're using the equal sign to mean the verb is, but the equal sign is being used in two different meanings or senses in the premises versus the conclusion. In the premises, the equal sign is indicating what's called the is of predication in logic, where you say 2 is a number, you're saying 2 is not identical to the concept of number, but rather that it's a member of the set of numbers. It has the predicate of being a number. Whereas in the conclusion, 2 equals 1, the equal sign is being used to express identity, i.e. two things are actually the same. So the is of predication is different from the is of identity. And because of that change in meaning, that's what makes this argument invalid. A sound argument is one that is both valid and has all true premises. So this basically is the best type of argument you can have when you're talking about deductive arguments. Deductive arguments are capable of being valid and sound, whereas inductive arguments are not. We'll talk more in the next video about how inductive arguments are evaluated. An unsound argument is one that's not sound, and there's two ways that can happen. It can be either invalid or it can have at least one false premise. And it's also possible for an unsound argument to be both invalid and have false premises. Either way, if it's invalid or has a false premise, then that's enough to make it unsound. An argument form is the general logical structure of an argument, which can be expressed by logical terms, such as if and then, and by variables, such as p and q, that stand either for particular terms or for whole statements. An example of a particular term would be dog or beagle. An example of a statement would be, if it's a beagle, then it's a dog. So a statement has a truth value. It can be either true or false, whereas a term is just a name for a predicate or a group of things. A substitution instance looks at a general argument form and then substitutes particular terms or statements for the variables. In symbolic logic, we generally use capital letters to stand as variables that could represent any possible statement. So specifically in propositional logic or propositional calculus, the capital letters are variables that can be instantiated by any statement. And the reason why we do this is because we can look at the general form of an argument regardless of the particular statements in it to discover whether it's valid or invalid. So this is why validity is such a powerful concept. Even if we're not sure what the particular statements are or whether they're true or false, we can still determine if the argument form is valid or invalid. So let's look at a particular substitution instance of that general argument form. The general argument form is if P then Q, if Q then R, therefore if P then R. The substitution instance is if it's a beagle, then it's a dog. If it's a dog, then it's a mammal. Therefore, if it's a beagle, then it's a mammal. This is a valid argument form because if the premises were true, the conclusion would have to be true. A counterexample to an argument is one substitution instance that shows the argument form can have true premises and a false conclusion. So here's another argument form. If P then Q, if R then Q, therefore if P then R. If we had a substitution instance of this argument form that had premises we know are true and a conclusion we know is false, then that counts as a counterexample to the general argument form. It shows that the general argument form is invalid. So here is a counterexample that's a substitution instance of this argument form with true premises and false conclusion. If you're a student, then you're a human. If you're a professor, then you're a human. Therefore, if you're a student, then you're a professor. So we know that the premises are true, but the conclusion can be false. Not all students are also professors, and in fact, most aren't. So that's enough to prove the whole argument form is invalid. So this counterexample method is one way to test if an argument form is valid or invalid. The power of the counterexample method is that all it takes is one counterexample to an argument form to show that the argument form in general is invalid. So if you had by analogy, if you had a theory that all swans are white, all it would take is one black swan that you observe to disprove that theory. So it's similar to the counterexample method. All you need is one substitution instance of an argument form with true premises and false conclusion to prove that the whole form is invalid. The limitation of the counterexample method is that it cannot show that an argument form is valid. We need to use other methods to do that. So even if you have a bunch of substitution instances that don't have true premises and false conclusion, you will never be able to prove definitively that the argument form is valid, because it's always at least possible that there's another substitution instance you haven't thought of that does have true premises and false conclusion. By analogy, even if you've observed thousands or millions of white swans, it doesn't prove definitively that all swans are white. It's always possible the next swan you observe will be black and will disprove your theory. So this is the same with the counterexample method. The way you prove definitively that an argument form is valid is by using truth tables, which we'll do in chapter 7. For now, we're just going to learn some of the names of common valid and invalid argument forms that can be used as helpful tips to test whether a new argument we see is valid or invalid based on whether it matches one of those forms. So we also should discuss the difference between simple and compound propositions. Simple propositions are ones that do not contain multiple propositions or logical operators as parts. Remember that the proposition is the underlying meaning, the logical meaning of a statement. Ultimately, in logic, what we care about is not particular statements, which are particular arrangements of words that express a proposition, but rather the underlying meaning of the statement. If you have multiple statements that express the same idea, they make the same claim about the way the world is, they count as the same logical proposition. In propositional logic, which is the main focus of this course, we use capital letters such as P to stand for simple propositions. For example, if you take the simple proposition, you live in Pasadena, you could use any capital letter to symbolize that. In this case, we've chosen P. It's often helpful to choose a capital letter that has something in common, usually the first letter of one of the words of the proposition, to help you remember which capital letter, which variable stands for which proposition. You'll notice this proposition, you live in Pasadena, it cannot be broken down into smaller components, smaller propositions, so it counts as one simple proposition. A compound proposition contains either multiple simple propositions or one or more logical operators as parts. An example of a logical operator is if. So here's an example of a compound proposition. If you live in Pasadena, then you live in California. We can symbolize this by if P, then C. In this case, we know it is a compound proposition, not only because it contains the logical operator word if, which we'll talk more about logical operators later, but also because it contains two simple propositions as parts. You live in Pasadena. That on its own is capable of being true or false, so it counts as a proposition. You live in California. That is also something that has a truth value. It's capable of being true or false, so it alone counts as a simple proposition. So then the whole must be a compound proposition. So let's look at some of the main types of compound propositions. Conditionals are compound propositions that have the form if P then Q. The if clause is called the antecedent because it comes before, generally, ante means before, and the then clause is called the consequent because it generally is the thing that follows or comes consequently to the antecedent. So you can have conditionals which are arranged in different order, Q if P, and conditionals don't always have the word then in it, but most commonly it will have both if and then, and if will come before then. Either way, whichever clause follows if is going to be the antecedent, and the other clause is going to be the consequent. So for example, if you live in Pasadena, then you live in California. A conjunction is a compound proposition with the general form P and Q. P and Q, or whatever propositions are joined by and, are called the conjuncts of the conjunction. And we don't have different names for the first conjunct and the second conjunct, unlike for conditionals, where we call the first part antecedent and the second part consequent. The reason why we don't have different names for first and second conjunct is because if we reverse the order Q and P, it has the same logical meaning as P and Q. You're saying that both are true in any case. However, with conditionals, we do have separate names for antecedent and consequent because if you reverse the order, if P then Q becomes if Q then P, it has a different logical meaning. So you've changed the conditional. Here's an example of a conjunction. You live in Pasadena and you live in California. A disjunction is a compound proposition with the general form P or Q. The propositions that are joined by the word or are called disjuncts. Similarly, as for conjunction, we don't have a different name for the first and second because if we switch the order, it has the same general meaning. Here's an example. You live in Pasadena or you live in California. If you switch the order, you live in California or you live in Pasadena, it has the same general logical meaning. It's true under the same conditions. A negation is a compound proposition of the general form not P. So here's an example. You don't live in Pasadena. So now we're going to look at some common valid and invalid argument forms. A common valid argument form is called modus ponens. This has the general logical form if P then Q, P therefore Q. With modus ponens, as with other argument forms, if you switch the order of the premises, it still counts as the same logical form. So if you had P, if P then Q, therefore Q, it would still count as modus ponens. The reason for this is that the argument form is trying to derive the conclusion logically from all the premises taken collectively. So it doesn't matter which order the premises occur in. Here's an example or a substitution instance of this general logical argument form. And I will often be using examples of celebrities or from popular culture to make them easier to remember. I will also often be using as examples social rules and violations of social rules. This is because it's easier for human minds to understand logical arguments in cases that involve following or breaking laws or social norms. This may actually give a clue to how the human mind evolved. In fact, perhaps much of our cognitive ability was mainly evolved in order to analyze social situations. This is speculation, but it is known that humans are much better at reasoning in social contexts than in other more abstract contexts. And this can be leveraged in order to help you learn the logical rules. So here's an example. If a person is 22 years of age, then they are legally permitted to drink alcohol. Kylie Jenner is 22 years of age. Therefore, Kylie Jenner is legally permitted to drink alcohol. Not only are the premises and conclusion true, But you can easily see if the premises were true, then the conclusion would have to be true. So even if Kylie Jenner is older than 22, the argument would still be valid, because if the premises were true, then the conclusion would have to be true. Another argument form that's invalid is called affirming the consequent. This looks very similar to modus ponens, so it can often be mistaken for it, but it has a different form. The form is if P then Q, Q therefore P. The difference is that the second premise affirms the consequent of the conditional rather than the antecedent. Modus ponens affirms the P, the antecedent, whereas this affirms the Q, the consequent, in the other premise. And then it tries to conclude that the antecedent is true. So here's a counterexample that shows why this is invalid. If a person is 22 years of age, then they are legally permitted to drink alcohol. Beyoncé is legally permitted to drink alcohol. Therefore, Beyoncé is 22 years of age. She's actually older. So it's easy to see in this case that the premises are true, but the conclusion is false, which means that the entire argument form must be invalid. Another example of a valid argument form, modus tollens. This has the general form, if P then Q, not Q, therefore not P. Here's an example. If a person is 22 years of age, then they are legally permitted to drink alcohol. This baby is not legally permitted to drink alcohol. Therefore, this baby is not 22 years of age. In this case, it has true premises and true conclusion, but that's not how we know it's valid. We know it's valid because regardless of how old this baby were, if the premises were true, the conclusion would have to be true. Another invalid argument form, denying the antecedent, and this one looks similar to modus tollens, but modus tollens denies the consequent of the conditional, whereas denying the antecedent denies the antecedent instead. It has the general form, if P then Q, not P, therefore not Q. And here is a counterexample. If a person is 22 years of age, then they are legally permitted to drink alcohol. Beyoncé is not 22. Therefore, Beyoncé is not legally permitted to drink alcohol. We know the premises are true, but the conclusion is false, so that's enough to prove this whole argument form is invalid. Here's another valid argument form, hypothetical syllogism. It has the general form, if P then Q, if Q then R, therefore if P then R. Here's an example. If you're a Catholic, then you're a Trinitarian. If you're a Trinitarian, then you believe that Jesus is God. Therefore, if you're a Catholic, then you believe that Jesus is God. Once again, even though the premises and the conclusion is true, that's not enough to prove it's valid. So hypothetically, even if we knew one of those premises were false, we could still say, well, if the premises were true, the conclusion would have to be true. So that makes the argument valid. Here's another valid argument form, disjunctive syllogism. It has the general form, P or Q, not P, therefore Q. Here's an example. Either you come to class or you must study the material on your own. You did not come to class. Therefore, you must study the material on your own. If the premises are true, the conclusion must be true. Let's look at some sample problems. In this problem, we have to create a counterexample to the argument form. That is, an example that has premises we know are true, a conclusion we know is false, and that fits the general form of the argument. Let's look at the first argument form. A was born before 1959. B was born before 1989. Therefore, A was born before B. So here's a possible counterexample to that argument form. Muhammad was born before 1959, in around 570 CE. Jesus was born before 1989, in around 4 BCE. Therefore, Muhammad was born before Jesus. So the premises are true, the conclusion is false. So we know this argument form is invalid. So just because someone was born before 1959 and someone else was born before 1989, we don't know how far before those years either one was born. That's the logical problem with this argument. Another sample problem where we have to create a counterexample. Fernando spent half of his income on his car. Andrea spent a quarter of her income on her car. Therefore, Fernando spent more than Andrea. So we have to create a counterexample of this by substituting particular values for premises 1 and 2. So we can create a counterexample if we assume that Fernando's annual income is $50,000 and Andrea's annual income is $200,000. So if we assume this, then Fernando, if he spends half of his annual income on his car, that's $25,000. If Andrea spends a quarter of her annual income on her car, that's $50,000. The conclusion is that Fernando spent more than Andrea, but it's false that $25,000 is more than $50,000. So the reason why this argument is logically invalid is because just because half is a larger proportion than a quarter, it doesn't mean that half of x is going to be larger than a quarter of y. It depends on the values of x and y. Let's look at another type of sample problem where we're given an argument and we have to identify the logical form of the argument and then say whether it's valid or invalid. If animals have rights, then animals can drive. Animals have rights. Therefore, animals can drive. What is the argument form of this argument? If R, then D, R, therefore D. So once we have outlined the logical argument form, it should be easier to identify which of the forms it fits. This fits the pattern of modus ponens, and it is a valid argument form. Remember, valid arguments can have a false premise or false conclusion. Valid just means that if the premises were true, the conclusion would have to be true. So the reasoning of this argument checks out, even though it has a false premise. Another sample problem. If animals have rights, then animals can drive. Animals cannot drive, therefore animals don't have rights. The general form of this argument is if R, then D, not D, therefore not R. So what is the argument form? This is modus tollens. It is a valid argument form. Once again, remember that a valid argument can still have a false conclusion, but the only way that's possible is if at least one of its premises are false. Another sample problem. If bananas are fruit, then bananas are plants. If bananas are plants, then bananas use photosynthesis. So, if bananas are fruit, then bananas use photosynthesis. So we're going to begin by looking at the general logical structure of the argument. This argument has the form if F then P, if P then H, therefore if F then H. So remember that we can use any capital letter we want to stand for a simple proposition. So the simple proposition bananas are fruit, we could symbolize that by any letter between A and Z. It's helpful though to choose a letter that helps remind you of the simple proposition. Another thing to keep in mind is that when you choose a given letter to stand for one simple proposition, you cannot reuse that letter to stand for a different simple proposition in the same argument. So we already used P for bananas are plants. We cannot reuse P for bananas use photosynthesis. In this case, I chose H because it reminds me of the H, which is the second letter in photosynthesis. So what argument form is this, and is it valid? This is hypothetical syllogism, and it is a valid argument form. Another sample problem. If you live in Anaheim, then you're an Angels fan. You're an Angels fan, therefore you live in Anaheim. So we begin by looking at the general logical form of this argument. If L, then F, F, therefore L. So what is the argument form? This is affirming the consequent, which is not valid. So notice that the second premise, F, is the same as the consequent or then clause of the first premise. If L, then F, F, therefore L. If this were modus ponens, it would be if L, then F, L, therefore F. Modus ponens is valid, affirming the consequent is invalid. Another sample problem. Either you're a Dodgers fan or you're an Angels fan. You're not an Angels fan, therefore you're a Dodgers fan. So what is the general logical form of this argument? D or A, not A, therefore D. So we only learned one logical argument form that uses the or as one of its premises. Do you remember what logical argument form that is? It's disjunctive syllogism, which is a valid argument form. And once again, it's possible for a valid argument to have a false premise or a false conclusion. So for example, It's not true that either you're a Dodgers fan or you're an Angels fan. You might be neither. Another sample problem. If you live in Anaheim, then you're an Angels fan. You don't live in Anaheim, therefore you're not an Angels fan. What is the general form of this argument? If L, then F. Not L, therefore not F. What argument form is this, and is it valid? This is denying the antecedent, so it is invalid. Unlike modus ponens, the second premise negates the antecedent, not the consequent. If it were if L then F, not F, then it could be modus ponens. Instead, it is if L then F, not L. That denies the antecedent or if clause, and this makes it an invalid argument. Next up, part 8, strength. This is the criterion we use to evaluate inductive arguments, which means how probable do the premises make the conclusion? If we assume the premise is true, do they help prove the conclusion is highly probable?